Hey guys, welcome back to the Monday videos for your Luna 4th grade uplift channel. Today we're going over comparing fractions. So this will be the end of our fractions section. We've already worked on what fractions are. They're just parts of a whole. We've looked at a regular fraction. We've looked at improper fractions where our part is greater than our whole. With those improper fractions, we looked at taking them and turning them into mixed unit fractions. So we have a whole number and then our fraction. And today we're going to work on comparing our fractions. All right. When we are comparing fractions, especially when we're giving these in word problems, this is the language that we need to be looking out for. So more than, less than, equal to. You can also see it as which one is greater, which one is smaller, things like this. But this is a language that tells us that we are comparing things. That can be an addition problem, a multiplication problem. Anytime you see language like this, you need to understand that you are comparing two things, which means you actually have to maybe figure out what one of them is, then compare them to each other. And then alongside those vocabulary words that we look for, we also need to recognize the symbols, right? More than, you've been taught this since 1st grade. It's an alligator mouth, right? And the alligator eats the biggest number. Less than, if this is a number, the first number we're talking about when we're comparing, we would say blank is less than blank. But again, your alligator is eating the bigger number. And then finally, equals to. Both of them are the same once we've compared them. All right, so when we have our fractions, with these fractions here, I use 3/4 and 5/8. There's a few different ways we can look at them, draw it out to compare it. So the ones we practiced with drawing them out, we practiced drawing out tape diagrams, and we practiced with drawing them out on number lines. Now remember, when we do make it as a tape diagram or a number line, it is very important that both of those fractions, the tape diagram or the number line for both of those fractions, are equal. If you're drawing one larger than the other, then you can easily get a wrong answer. So when I look at the tape diagram, I drew out 3/4. There's 1, 2, 3, 4 parts that make my whole, and of those 4 parts, 3 are colored in. So that shows 3/4. For my tape diagram with 5/8, I actually started it the same way I did my tape diagram for 3/4. I just drew the hole, I found my halfway point, and then from there I realized 8 and 4 go together, right? 4 is half of 8, so I continued where my 4th line would be, and then I drew in my other line. So now I have 8 total parts. Of those 8, 5 are colored in. So when I look at these two tape diagrams, one on top of the other, I can clearly see that 3/4 is greater than 5/8. And I did the same thing with the number line. Okay, when you draw your number lines, they need to be the exact same size, the length. All right, and what we did, if you remember what we did in class, was the very first thing we did is we labeled the endpoints, the 0 and the 1 hole, and then we went straight to a halfway point. So what I didn't do here, but I remember we would do in class, is before we even labeled this with the fraction that we are in, either 4ths or 8ths, we would label this 1/2. That way, if we were comparing halves and 4ths, we could already see 1/2 is the same as 2/4. All right, so after you label the halfway point, then you can put in your others. So here's 1/4, here's 3/4, 1/2 would be 2/4. And we could do the same thing here. We could show that the halfway mark is the same as 4/8. All right, and then we labeled in the rest of our eighths, 1/8, 2, 3, 4, all the way to the end, 8/8. And the other thing we would always label is at the very end, 4/4 is the same as 1 whole, 8/8 is the same as 1 whole. Once you have your whole table diagram or your number line labeled, you can go ahead and find your point. So here's 3/4, here's 5/8. I can clearly see 3/4 is greater then 5/8. And the last way we learned to do it was to change our fractions so that they both had the same denominator, the same number on the bottom. And we did that by finding common multiples. So what I did here was I wrote out 3/4 and I wrote up 5/8. Now remember, when we're doing this, we're only changing our denominators. Now, luckily for us, when we wrote out the multiples for 4, remember, multiples are what can I multiply 4 by to get a multiple of it. So 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 16, 4 times 4 is 20. I did the same thing with 8. 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24. I didn't go any further after that. So when I look at common multiples, I see they both have 8 in common and they both have 16 in common. Well, to make life easier for myself, I chose 8. That way I wouldn't have to change this one. Remember, what we're looking for is what we're changing the bottom number to. So if this one is going to stay 8, 5/8 is fine. You can leave it. If we're changing the 4 to 8, we have to figure out 4 times what gives me 8? Well, 4 times 2 gives me 8. And as we remember, if you do it to the bottom of a fraction, you must do it to the top. So I did 3 times 2 is 6. So changing my fourths here to eighths, 3/4 is the same as 6/8. Another way we could have shown that we know this. Okay, so now that we've gone over the different ways to do it, I'm going to solve this and we can go through it all 3 ways. All right, so we're comparing 1/10 to 3/8. All right, so I have my tape diagram and my number line ready. So my first one up here, my first tape diagram is separated into tenths. My bottom is separated into eighths. Same with my number line. So with 1/10, I'll shade in 1 part out of my 10. For the 3/8, shade in 3 parts out of my eighths. And I'll do the same with the number line. Okay, this is my halfway point. If I were to label it all, that's my halfway point. Also 5/10. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 1/10. If I were to have labeled my whole number line, that's my halfway point. That was also the 4/8 mark. There's 3, 2, 1. There's 3/8 right there. Okay, looking at both my tape diagram and my number line, I can see that the 3/8 mark is greater than the 1/10 mark. And same thing, if I were to do this here and finding a common multiple, I want to change both of my bottom numbers so that they are the same. It's so much easier to compare, right, when you're comparing the same number. So I look at common multiples. Multiples for 10 would be 10, 20, 30, 40. Multiples for 8, we're looking at 8, 16, 24, 32, 40. So what I notice is both of them have 40 in common. So what I'm going to be doing is changing both these fractions into 40th. I just have to figure out how do I get to 40th. So if I look at 1/10, I have to figure out how did I get from 10 to 40. Well, I multiplied that by 4. And the rule is if you multiply the bottom by 4, you have to multiply the top by 4. So it would be 4 40ths. All right, same thing with the 8. I started with my fraction 3/8, and I have to ask myself, how did I get from 8 to 40? Multiplied by 5. If I do it to the bottom, I have to do it to the top. 3 times 5 is 15. So now that they're both in 40ths, I can easily see 15 is greater than 4. So when I go to answer this, I would say 1/10 is less than 3/8. That's a symbol I'm looking for. Now, the last thing I'm going to show you is what we call the butterfly method, or cross multiplying, to figure out the answer. This is going to be the easiest way to do it, but the reason we show you this way first is so that you can understand. It's called conceptualization. You can see why what we're about to do works. So we start off with 1/10, then 3/8, and we are just cross multiplying. So the cross multiplying means the top and the bottom of the other. So 1 times 8 is 8. 10 times 3, or I would have put the 8 up here, that's why. And 10 times 3 is 30. So I'm left with 8, and I'm left with 30. 30 is greater. So the butterfly method works, the cross multiplication works, but we teach this so that you can understand why it works. So when we did the butterfly, 10 times 3 is 30, 8 times 1 is 8, 30 is greater than 8, so 3/8 would be greater than 1/10. How do I know that for sure? Well, this is how I know for sure. I drew it out, right? Or I changed them both to multiples, the same multiple of 40, and I could easily see the 3/8 was always going to be greater.